Hey, what's up? Tristan from Huge Menace here. Welcome to part 3 of the ND add-on deep dive series. In this video, we'll cover booleans. They allow you to quickly cut and shape objects and create geometry that would otherwise be rather painful to construct via traditional polymodeling techniques. Let's get started. We'll start by going through the 3 fundamental boolean types: difference, union, and intersect. These 3 booleans are essentially the same operation with different parts of the object left at the end. We'll use 2 objects for all of our examples, as that's all Blender and therefore ND supports in one operation. Of course, you can run multiple booleans in succession. We'll refer to these 2 objects as the target and utility. The utility object is often called the cutter, which can be misleading as it only sometimes cuts or removes geometry. A difference boolean will remove geometry from the target, specifically the geometry intersecting with the utility. A union boolean will merge 2 objects together. An intersect boolean will remove geometry from the target object, leaving only the geometry behind that intersects with the utility. This is the opposite of the difference boolean. Let's go through some live examples. First up, difference. Here I have 2 partially intersecting cubes, green and red. In these examples, green is always the target and red is the utility. First, we need to select the cubes in the correct order. The selection order defines which cube will be the utility and which will be the target. To make it easy to remember, the last object you select will always be the target of the Boolean operation, as it's the active object. So let's start by selecting the red cube, followed by the green cube. Then choose the difference Boolean from the ND main menu. We've successfully removed material from the green cube using the red cube. The neat thing about this technique is that it's completely non-destructive, and you can easily change the result in real time. Try moving the wireframe structure that was once the red cube. So, what happened to the red cube? ND converted it into the utility object we discussed, and placed it into a new collection called utils. ND also changed the object's display mode to wireframe, making it easier to see the operation's effects without the utility obscuring your view. Finally, ND parents the new utility object to the target, ensuring the 2 objects maintain their original relative positions. If you no longer want to see the utility objects in your scene, you can toggle the visibility of all utils via the viewport menu, accessible via the ND main menu, or the dedicated menu bound to Alt V. Now, the difference boolean also has 2 alternative modes. The first, which you can activate by pressing the Shift key, protects the object being used as a utility. This means ND will not change its display mode or move it into the utils collection. However, ND will still use it to perform the operation and parent it to the target object. It's hard to see what happened in this case as the object obscures the resulting boolean, which is one of the reasons ND changes the display mode of utilities to wireframe. We can, however, confirm that it worked if we apply the boolean modifier to the green cube and then move the red cube out of the way. This mode is not the most common way to use utilities in ND, still, it is handy in certain situations we'll likely cover in more detailed tutorials. You can activate the second alternative mode by pressing the Alt key. This mode will skip the initial cleaning step ND performs on a utility object before using it in a Boolean operation. The cleaning step involves removing some generally unwanted modifiers, such as bevels, from the utility object. However, there are cases where you want to maintain the utility object's modifier stack, hence this mode exists. Let's take a look at the next fundamental Boolean, union. The steps are identical to the previous example. First, select the utility object, then the target object, and run the union Boolean operation. You can confirm this by running a follow-up operation, such as a bevel. Like the difference Boolean, a union is non-destructive. You can update it in real time. The last fundamental Boolean type is intersect. You know the drill by now. Let's select our utility and target objects and run the Boolean operation. An intersection results in the target object having all material removed that doesn't intersect with the utility object. Another way to think about it is that the result of an intersection is the geometry that a difference Boolean would have removed when performed on the same 2 objects. This behavior leads us to the first specialty Boolean type we'll discuss, slice. Let's take our 2 objects and run a slice Boolean. As a result, we get both a difference and an intersection Boolean simultaneously. It might be hard to see in this example, but we can make it much more apparent by adding a bevel to both resulting objects. As you can see and hopefully derive from its name, the slice boolean operation slices the original object into multiple parts based on the intersection area of the utility object. The second specialty boolean type is inset-outset. Let's take our two objects and run an inset-outset. We get a unique result which appears to eat away at the target object, but not quite the same way a difference boolean might. The inset-outset boolean eats away at the target object by the inset-outset amount. If you switch modes, the opposite happens, resulting in the operation adding material to the target object. For a more practical example, let's create an inset encompassing the green cube's center using the inset-outset boolean. We'd start by creating a utility object intersecting the area we want to affect, then run the inset-outset boolean, and here's the result. Finally, ND offers two additional operators that support your boolean workflow. The first one is called hydrate. If you ever want to reuse the original utility object for another boolean, or you want it back to use somewhere else in your scene, start by selecting the utility object's wireframe cage, then select hydrate. The first option is where to place a new object. I'll unparent it from the target object as I want to use this new object for a different purpose. Once ready, let's confirm the operation. You should now have a rehydrated copy of your original reference object that you can use however you want. Okay, the last operator in the Boolean collection is swap solver. A bit of context is necessary for this. By default, Blender's underlying Boolean algorithm uses the fast solver. As the name suggests, it's fast. However, it comes at the cost of precision. For most situations, the fast solver is sufficient. However, there are circumstances where it breaks down. Let's take a look at one of those situations. In this example, the sides of our utility object touch the sides of the target object. Now let's run a difference boolean and see what happens. The result? Unexpected. As mentioned previously, the fast solver's lack of precision is why we encounter this problem. Select the problematic utility object and choose the swap solver operator to correct it. With the swap solver open, you can hit the S key to swap between fast and exact. As we can see, exact results in a boolean we'd expect to see. A word of caution, exact is a more sophisticated solver algorithm and comes at a performance cost, which is why fast is the default. With too many booleans set to exact, Blender's performance will take a noticeable hit, depending in part on your computer specs. Stick to the fast solver and use the exact solver as a fallback if the fast solver produces an undesirable result. Well, that wraps up booleans. In the following video, we'll cover everything related to bevels. I'll see you there.